something else that's cool about series. Let's take sine of x, all right? What happens if we were to derive this right side of the equation here, our polynomial? What's the derivative of x? Yeah, it's 1. How about the derivative of x cubed over 3 factorial? Well, the 1 over 3 factorial, that's a coefficient, so it's going to stay. And then we have x cubed that needs to be derived. What does x cubed derive to? Yeah, 3x squared. All right, hold that thought. Let's go to the next term. Same idea. 1 over 5 factorial is a coefficient, so when we derive it, it stays. And how about the derivative of x to the 5th? 5x to the 4th. Right, and why not one more? So we have minus 1 over 7 factorial times 7x to the 6th. All right. Well, what happens when we kind of simplify this a little bit? 1 over 3 factorial. 3 factorial is really 3 times 2 factorial. And this 3 and that 3 eliminate each other. So what do we end up having? 1 minus x squared over 2 factorial. Take a look at this term. 5 factorial, that's 5 times 4 factorial, right? But the 5s eliminate each other. So we have x to the 4th over 4 factorial. Some of you are seeing where we're going with this. All right, the next one, 7 factorial. That's the same thing as 7 times 6 factorial. The 7s eliminate each other. We have minus x to the 6 over 6 factorial. What is this series right here? Yeah. It's the cosine of x. What did we do to the right side of the equation? We derived it. If we derive the right side of the equation, we got to derive the left side of the equation. What's the derivative of sine? It's cosine. So not only can we substitute an inner function for x and create a new series, once we have a series, we can also derive it, or even better, we can integrate it as well and come up with new series in that regard. And that's what the next couple of examples are. It's a matter of finding a derivative and finding an antiderivative, right? And it's real easy to derive and antiderive these polynomials. That's really why we're getting into these series. Polynomials are so much easier to work with than functions that involve trig or exponentials or logarithms or inverse trigonometry. Why not just use the polynomials? It's a lot easier way to go. And that's one of the key points behind a power series and why it's so important.